Hey kids, Flexing Teacher Weber here. Now that we've learned about how the distributive property is something we've used before when we multiply numbers, we can apply the distributive property to algebra expressions. Now let's take a look at a simple algebra expression, and we want to expand this expression or simplify it. So what we want to do is when we expand it, we want to make these parentheses go away. So to do that, we have to think about what it means. Now this means 3 times y plus 2, or a better way of thinking that is 3 groups of y plus 2. So let's write out 3 groups of y plus 2. So I'm going to write out y plus 2 and y plus 2 and y plus 2. That's 3 groups of y plus 2. And remember, even though we don't see it, in front of each variable there's a 1. Now, what we have here are a bunch of like terms, and yesterday we learned about grouping up like terms and using integers to do that, and you can only group up terms that have the same variable part. So there are 3 y variables, so that would be 3y. And positive 2, positive 2, positive 2, positive 2 make positive 6. And that's called expanding that math expression, expanding it to make the parentheses disappear. And that's as far as we can take that question. Now I want you to look at sort of a shortcut we could use as well. So we solved that by adding the integers. We could also solve it by multiplying the integers. Look at the shortcut here. We could do 3, I'm going to erase that. We could do 3 times y and 3 times positive 2. And it's important you remember the sign in front of that integer goes with the integer. So 3 times y and 3 times positive 2. And when you do 3 times y, you get 3y. And when you do 3 times positive 2, you get positive 6. You should be familiar with how to do both of these things. All right, that's a basic question. Let's try another one. Doink. 4 groups of x minus 7, or 4 times x minus 7. Well, 4 groups of x minus 7, let's expand this out. That's going to be x minus 7, x minus 7, x minus 7, and x minus 7. Pardon me. And now we can use like terms to total up those expressions. Remember, in front of each variable, if there's nothing there, that's a 1. So if we total up our x's, we have 4x. And if we total up our negative 7s, it's important you remember that the sign in front of the integer goes with that integer. So we have negative 7, negative 14, negative 21, negative 28. So that expression expanded out without the parentheses is 4x minus 28. The shortcut, 4 times x and 4 times negative 7. And if you do that, you will get the correct expression. You need to understand both ways. This way right here shows a really good understanding of your expressions and your algebra. This way right here is just a quick way to get the answer. Let's try another one. Doink. Ooh, getting a little harder now. Okay, this means we've got a negative 5 multiplied by n plus 6. So the negative on this 5 is really important. This negative means you're going to do the opposite of everything in the parentheses. So here's what I mean by this. 5 groups of n plus 6, but the opposite of the sign that's in front of each of those terms in the expression. So it's not positive n, it's going to be negative n. And it's not positive 6, it's going to be minus 6. We're going to do the opposite of what's in front of each term. So the opposite of positive 6, negative 6, the opposite of positive n, negative n. And we're going to do that 5 times. Negative n minus 6, negative n minus 6, negative n minus 6. Keep on going. Negative n minus 6, 5 times. And remember, even though we don't see it in front of each of those n's, 1, 1, 1, 1, 1. Okay, essentially what we're doing now is adding up integers. Negative 1, 2, 3, 4, 5. So that's going to be negative 5n. And negative 6, negative 12, negative 18, negative 24, negative 30. Doink. There's our expression expanded out. Now let's see if the shortcut method would work here. Okay, negative 5 multiplied by n would be negative 5n. And negative 5 multiplied by positive 6 would be negative 30. So it absolutely does if you remember that the sign in front of the integer belongs to that integer, and you have to include those signs when multiplying. Let's even get a little trickier. Doink. Ooh, a 3-term expression. 3 groups of negative x plus 2y minus 7. Now, even though you don't see it, in front of that x, there's a 1. Okay, so 3 groups of this. Negative 1x plus 2y minus 7. Negative 1x plus 2y minus 7. And negative 1x plus 2y minus 7. Okay, and what we're doing now is grouping up our like terms. Negative 1, negative 1, negative 1 is negative 3x. Positive 2y, positive 2y, positive 2y, positive 6y. Negative 7, negative 7, negative 7, negative 21. The shortcut. Positive 3 and negative 1. Multiplying those gives you negative 3x. Positive 3, positive 2. Multiply those gives you positive 6y. And positive 3 times negative 7 gives you negative 21. There you go, kids. The distributive property in algebra. The reason we use this is to simplify expressions by making the parentheses disappear. One last question. Doink. Negative 2 groups of 2x plus 3y minus 6. And remember, in front of that negative 2, there's a negative sign, which means we're going to do the opposite sign of every term in the parentheses. And we're going to have 2 groups of this. So it's not 2x, it's going to be negative 2x. It's not positive 3y, it's going to be negative 3y. And it's not negative 6, it's going to be positive 6. And we're going to do that 2 times. So negative 2x, negative 3y, positive 6. We did that 2 times. Let's total it up. Negative 4x minus 3 is negative 6y. Positive 6 is positive 12. And that's as far as we can take that because we can't group up the like terms any further. Using the shortcut, negative 2 times positive 2x gives me negative 4x. Negative 2 times positive 3y gives me negative 6y. And then finally, negative 2 times negative 6, a negative times a negative is a positive 12. And that's as far as we can take that expression. You need to be able to recognize both ways to solve these. And after we practice this some more, we're going to take the distributive property a step further. So use these ideas we've just talked about on your assignment today. Flexing Teacher Weber, out.